Hello, Algebra 2. Welcome to our first video for Chapter 6. We're starting a new chapter. We went ahead and closed up our little book on Chapter 8, which was rational functions. Okay, we're going to move on to some new stuff just to kind of keep the wheels turning. We're going to talk about a different type of exponent in this chapter, as well as a new function called a radical function. Okay, also known as a root function. We call we call it the same, those two names, root function or radical function. Okay, so that's kind of what you have coming up in this chapter. So before we get there, of course, we're going to start with section 6.1. We're going to do evaluating nth roots and using rational exponents. Okay, so what does that mean? Well, our objectives are to find nth roots for different values of n. So kind of the idea for today is an nth root. What is that? We're going to raise numbers to rational exponents. We're going to see what that means and see what they equal, kind of how to work with rational exponents. And we're going to solve equations using nth roots, okay? So let's just start off with what we know so far, okay? What do we know about roots? So we know that roots is another word for x-intercepts and zeros, but that's not the root we're going to talk about here. We're actually going to talk about the root that has to deal more with, for example, what would you do to solve this equation? Let's start with x squared equals 16. Okay, what would you do to solve this? Hopefully you're thinking, oh, I would take the square root of both sides. I would need a plus minus here. So then x is equal to plus minus 4. Okay, so far the root that we're familiar with as of right now is the square root, right? Square root. Okay, now what we want to do for this chapter is to kind of generalize it. Because why? Well, what would we do if we want to solve an equation like this? X cubed equals 27. Okay, we could brute force it and think, okay, what to the third power gives me 27? Oh, that's 3. So the answer is 3 here. But what if it wasn't a nice number? Say like x cubed is equal to 10. What number do I multiply by itself 3 times to get 10? If you think about it, there's not really a nice number. We have to actually go ahead and calculate this. So how do we get there? Really what we're going to do is we need something to, or what we need to do is we need something kind of similar to the square root, but we can't square root x cubed because that doesn't cancel out the cube, right? The square root cancels out the squared. We need something to cancel out the cube root or the third power. Sorry, the cubed. I kind of gave away the answer. The cubed part or the third power, okay? And that's what we call the nth root, all right? So let's kind of talk about the nth root for a little bit. So what is the nth root? When we say nth root, that is a general term, okay? So the nth root of some number, let's say a. Okay, here's how we're going to write it. We're going to write it using that radical symbol. This right here is called the radical, right? We hopefully remember that from a little bit ago. Radical. Okay, and then since it's the nth root, we're actually going to put a little n in the top left-hand corner next to the roof of the house, right? Next to the roof of the radical. And then our a is going to go in here. Okay, so what is n? Well, n is a whole number. Is a whole number bigger than 1, so greater than 1, not including 1. Okay, we can include 1, but it doesn't really mean anything to take the first root because it's just not defined for 1, right? So it's got to be 2 and up, whole number, and we call n the index. So n is called the index, okay? Let's go ahead and highlight some of our vocab words that we just learned. So we just learned nth root of a, and then index. That's what we call the n. That's what we're calling n here. Okay, so when n is 2, that's the square root, right? We're already very familiar with one of the cases. Okay, so when n is equal to 2, then our nth root is the square root. Okay, now there's not really much more fancy terms for higher n's except for 3. We call it, when it's n equals 3, we call it the cube root, as I kind of mentioned earlier on accident, right? And so that'll be when I do this. okay? And then it equals 4. We just call that, from then on, it's just kind of boring. It's just the 4th root. And then for 5, it's the 5th root, the 6th root, so on and so forth, right? But that just means we put that number as the index on the radical. Okay, so that's kind of how, and I forgot to write square root. So that's kind of how that stuff is going to work. Okay, now while we're on the same vein, okay, another way we can write this using exponent notation, we can write every single root as an exponent. So let's actually write that down, that way we remember that. Okay, we can write every nth root either, or sorry, actually maybe it'll be more grammatically correct to say we can write every nth root using either radical notation, and that's going to be, we'll write it below here. That's going to be our nth root of a, the thing we just saw, or exponential notation. We can use an exponent to represent this stuff. So exponential notation. Okay, and how does that work? Well, every single time we see this, it's equal to a to the power of 1 over n. Okay, these are the same. Maybe write this in big lettering, big size. This notation equals this notation. One way to write the nth root is a to the power of 1 over n. Okay, so maybe a little baby example before we continue. Let's say we talk about the square root of 25. Another way to write that is 25 to the 1/2 power, right? Because for the square root, the n, we don't ever write the 2 there because that's our base, that's our basis. So we just kind of leave it as the square root symbol. But just know whenever you don't see a number, it's implied 2. Okay, and so because of that, the fraction is going to be 1 over 2. Okay, let's say I had the cube root of 27, then that's going to be 27 to the 1/3 power, and so on and so forth, okay? So why don't we go ahead and practice with that? All right, so write the following using radical notation and exponential notation, and then we're actually going to find the value, okay? So let's start with the first one, the 3rd root of -216. Okay, so that's the verbalization. That's how we say it out loud. The 3rd root, and then actually we could also call this the cube root instead, right? We just talked about that. The cube root of -216. Okay, in radical notation, cube root, so that's going to be index of 3, and inside the house is -216. And then as an exponential, that's -216 to the 1/3 power. Okay, so we found, or we went ahead and wrote those in the different notations. Now let's actually find what these equal. So what is this equal to? Okay, well, normally we're not used to having negatives under the radical, and if we do, we usually have this I business. But for now, just ignore the negative, just pretend the negative's not there, and ask yourself, okay, now that we're working with cube roots, when we think of a square roots, we think, what times itself gives me that number? But now what we're asking, okay, if I want the, let's just start with the cube root of 216. If I want the cube root of 216, then I'm asking myself, what number to the 3rd power is going to give me 216? Okay, I want this number. All right. What do I multiply by itself 3 times to get 216? Okay, maybe play around with some numbers, pause the video for a bit, play around with some numbers, see what you can do when you multiply itself 3 times. Which number will give you 216? Okay, hopefully you're finding that the number is 6. Okay, so we want to write 6, but 6 times 6 times 6 is not positive, is not -216, right? And normally we're not used to negatives under the radical, but actually with the cube root, we're allowed to have negatives under the radical. Okay, try -6. Okay, what happens when we do -6 times -6 times -6, otherwise known as -6 cubed, right? What do you do when you do that? Well, -6 times -6, that's positive 36. 36 times negative 6, that's going to give us negative 216. Okay, so this cube root of negative 216 is actually equal to negative 6. Okay, cool. Let's try the next one. 4th root of 81. Let's write it both ways. 4th root of 81. That's our radical notation. And then 81 to the 1/4 power. Okay, so that's written in the different notations. Remember, those are equal. They look different, but it's quite the same thing. Okay. So then now, what is it equal to? Same question we ask ourselves. What to the power of 4 is going to give us 81? Okay, question mark. What is this number that we raise to the 4th power? So multiply by itself 4 times to give us 81. Okay, play around with some numbers. Pause the video for a little bit, see what you can come up with. Okay, and when in doubt, we're never going to work with gigantic numbers, you guys, and if we do, I'll have you use a calculator. So, start with 2. 2 times 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's not it. What about 3? 3 times 3 is 9, times another 3 is 27. Oh, and then times another 3 is 81, right? So this is equal to 3. Okay, because 3 to the 4th power is 81. So then that directly implies that the 4th root of 81 is 3. Okay, just like how square roots work, right? If something squared, so like if I know that 4 squared equals 16, then automatically I know that the square root of 16 is 4. Okay, we still have that very same relationship. All right, hopefully that sounds okay. Meet me in the second part of section 6.1 videos and we'll talk about this in a little more detail, okay? Actually, wait, just kidding. We have one more. Ooh, before you take off from this first part, we actually got to talk about the properties of the nth root. I saw that at the bottom. I was like, wait. Okay, one last thing before we finish this first part of the video. Let's talk about the properties, right? Because we kind of discovered something weird, right? We can take the cube root of a negative number, but we know we can't take the square root of a negative. Otherwise, we get some imaginary stuff, right? So let's talk about what that means, okay? So there's 2 different cases for n, right? We know n is a whole number, and we know it's bigger than 1. Okay, but now to be even more specific, okay, n can either be even or, oh crap, that was kind of ugly. There we go. Let's try that again. N can either be even, that's a lot better, or it can be odd, okay? And we're gonna have different cases for each of those, okay? So let's write down those properties for when it's even or odd. All right, so when n is even, no matter what, if we take an nth root, okay, what does that mean? That means that if I solve an equation, like for example, x squared equals, I don't know, some weird number like 21. When I take a square root, that means I put a square root, I use the root as the operation, okay? So if we take an nth root, meaning if we use an nth root as an operation, then we need plus minus in front. Okay, so plus minus. So that means that whenever for example, when we solve equations later with x to the 4th equals 16, for example, eventually we're going to have plus minus. The same thing if I had x to the 6th, x to the 8th. If I ever use the 6th root or the 8th root, we will use plus minus. Okay, so that's one property. Second property for even roots, then nth root of a negative number will not be real. Okay, we get imaginary. Okay, so whenever we do the nth root, so if we do a 4th root of a negative, we get an I, maybe not the same kind of I, we actually get a different kind of I. We won't focus on that in this class, but just know we still get some kind of imaginary number. Same thing with the 6th root and the 8th root and the 10th root, etc. Okay, now let's talk about when n is odd. So when n is odd, we never, so no plus minus in front when we take an nth root. Okay, so when I use the cube root, for example, in an equation, I don't get plus minus. And then possible to take the nth root of a negative number, as we saw with example 1, part A. Okay, negative number, sorry, that's a hashtag, negative number. Okay, so those are our properties for the nth root. Okay, when it's even, I need plus minus if I'm using it as an operation, and I can't take the nth root of a negative if it's even, if n is even. Now, if n is odd, then I don't ever put a plus minus when I use it as an operation, and I can take the nth root of a negative when it's odd. Okay, cool. Now that we have the properties settled down, let's go ahead and take a break, and then I'll see you in the second part of these 6.1 videos, okay?